Hi, it is Friday and this is 9.3b. So, the past 2 days we've just been practicing with breaking down, perfect squares or numbers and dividing things up to simplify. So, today we're going to have exponents in our math problems. So, I just want to kind of go over these numbers and information up here on top. 2 to the third is 8. 2 to the fourth is 16. So this is 2 times 2 times 2. That makes 8. And then 2 times 2 times 2 times another 2 would make 16. 2 to the fifth makes 32. These are all really important ones to remember because they come up often. 2 to the fifth, we got 3 cubed. 3 times 3 is 9. Oh, times 3. Oh, this should say 27. Okay? 3 cubed is 27. 4 squared is 16. Okay, we know that. 4 cubed is 64. 5 squared, 5 cubed. So, now, here is what's important. Did you know that a square root and an x squared, that these two negate each other? They are inverses, opposites of each other, and the answer is just x. It works the same thing if I had a cubed root. The cubed root of x cubed would just be cubed root negates a cubed, just x. The cubed root of a 4 cubed, these threes negate each other and it's just a 4. So these are all important parts. Now, the fourth root of x to the fifth. I need to look at my root, it's a fourth. And then I see that I have x to the fifth. Well, x to the fifth is going to be, needs to be broken up. So I'm going to break up x to the fifth so that it has a 4 somewhere. So what makes 5? Well, 4, because that's going to negate, and x to the first. Remember the rules. X to the fourth times x to the first, you add the exponents. That's going to be x to the fifth. So now, the fourth root of x to the fourth, this negates, and it comes out as just an x. However, I still have this one in here. So I still have to use my fourth root of x. So x times the fourth root of x is the answer. I don't need to put a 1. No one puts a 1. It's a waste of time. All right, let's practice these. 8. Well, that's 4 times 2. So this is review, easy. 2, square root of 4 comes out and it's 2. 2 root 2. Good. Now, 32 equals 2 to the what? Where is 32 up here? 2 to the what? 2 to the fifth. 2 to the fifth. Good. Number 3. There is no 2 here, but this is a square root. So look, squared, second power, squared, second power. They negate each other. So this 3 is going to come out as just a 3. The square root of 4 squared, the squared and the square root negate each other, and it just comes out as a 4. This would be 12. If you really wanted to make it extra work, you could make 3 squared and 9 times 16, and then you see, 3 times 4, and you would still get the 12. But there's no need for me to make it a 9 because I know that the squared and a second root negate each other. Number 4, the cubed root of 8 times 8. Well, I don't want you to do 8 times 8. I do not want you to multiply and make it 64. What I want you to do is I want you to make 8, look up here, 2 to the third. So the cubed root of 2 to the third times 2 to the third. That's going to be Look, they negate each other. The cubed root of a third power is just the 2 comes out. And then again, the cubed root of 2 to the third, the 3 and the cubed negate. A 2 comes out. The answer is just 4. Let's try number 5. Well, the cubed root of 3 to the third, I know that I can take that out. But 4 to the fourth, let's break up this 4 so that a 3, like I want this outer number to be smaller so that I can say, what is 4 to the fourth? How about 4 to the third times 4 to the first? That would be fine. So I now broke it up into something easier that I can work with. Because there's no way that I'm going to want you to multiply 27 times 4 to the fourth. No way. So the cubed root of 3 to the third power, out comes a 3. The cubed root of 4 to the third, out comes just the 4. So now what's still in there? What's still in there is going to be my cubed root of 4 to the first, which I just write as 4. I have to multiply this 3 times 4. 12 is 3 times 4 times the cubed root of 4 is my final answer. All right, 16y squared. Oh, this isn't too bad. You know, this is a square root. When there's nothing there, it's a square root, a 2. The square root of 16 is 4. The square root of y squared is just y. The answer is 4y. Number 7. The fourth root of 81. Well, looks like I didn't put up here 3 to the fourth equals 81. So I can do that. So 3 to the fourth equals 81. That means that instead of 81, I'm literally going to write 3 to the fourth power. Now x to the fifth. Break apart that. 5 becomes, or I could make a 4 out of it. There's a 4 inside of a 5. 4 plus 1, right? X to the fourth, x to the 1. That makes x to the fifth. And what about y to the sixth? Well, I can make a 6. I can break up a 6 into a 4 and then like a 2, a 4 and a 2. Y to the fourth, y squared. That makes 6. So the whole reason I'm doing this is because I want to match up this fourth root. So here we go. Let's simplify. The fourth root of 3 to the fourth is just 3. The fourth root of x to the fourth is just x. So once again, this 4 and this 4 negate. This 4 and this 4 negate. I can't touch the x to the first. That's going to stay under there. But y to the fourth, I'll be able to take that one out as just a y. The fourth root of y to the fourth, just y. Y squared, I can't do anything. Okay, now, what's still under that fourth root? Under the fourth root, I still have this x and this y squared. Xy squared. Good. Okay, let's look at this number 8. It's a square root, squared. So let's make things squared. Well, I know that 49 is a perfect square, so I can just take that out as a 7. M squared, the square root of m squared, just comes out as an m. And how about n to the fourth? Well, that can be n squared, can't it? So take out an n, this squared and that square root, this n squared, this squared and that square root. So my final answer is 7m and then n squared. Could have also said that like n to the fourth, the square root of 4 is 2. See this 4? That's how the 2 got there. So that's another option. Instead of breaking it apart. All right. The 7th root of f to the 9th. Well, let's break up f9. f7, f2. So the 7 comes out as just an f, but I still have to keep this f squared under there. And it's still a 7th root. I can't do anything because the root is bigger than what's inside. So I'm done with the front side of notes. All right, let's turn. So now I have variables again. So square root of 63x to the 9th. Well, 63. What kind of perfect square goes into 63? 4, 9, 16, 25. Oh, how about 9? 9 times 7. Now, x to the 9th, you guys, 9 is a perfect square. So I can, because it's a 9, I know that I can do a shortcut this time and say the square root of 9 is 3. Out comes this 9. It becomes a 3. X to the 9th, the square root of a 9 is x to the 3rd because the square root of 9 is 3. What's still inside though? That 7 is still inside. 3x cubed times the square root of 7 is the answer. 3x cubed times the square root of 7. Okay, 36 times x to the 5th. Well, 36 is a perfect square. It's 6. X to the 5th, let's break it up into 2's. X squared, x. That's 5. 2 plus 2 plus 1 makes 5. So, square root is going to be, this x squared comes out as just an x. This x squared comes out as just an x. The square root of x squared, but there's still an x1 inside. 6 x squared times the square root of x. All right, this last one. There's already a 2 out there, so leave it. No problem. 49, let me do it all under. Now, if this is a square root, because it is, I can go x2. I have to make 7. 2, 4, 6, 7. And then y squared would be y squared, y squared. All right. A lot of stuff is going to come out. 49 comes out as a 7. Remember, this 2 is still there. X squared comes out as an x. The next x squared comes out as an x. The next x squared comes out as an x. This x to the first is going to stay. This y squared comes out as a y. 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 I took a lot out. So, on the outside, I have a 14, 2 times 7, x to the 1, 2, 3, x to the third, y to the 1, 2, 3, 4, y to the fourth, and what's still under there? 1x all alone. And that's your answer. All right, cubed roots. Now remember from the front side. 3 to the third is 27. 3 to the fourth is 81. Remember that? So I can do 81 is 3 to the third, which is 27, times a 3, because I want to take out this 27 here. Or do you want to write 27 times 3? You could also just make this 27 times 3. X to the fifth, break it up into a little something that has a 3 in it, like 3 plus 2, make 5. X to the third, x squared, because now I'm going to be able to take out this x cubed right here. And then times y to the first. Can't do anything with that. All right. The cubed root of 27. Out comes a 3. This 3 stays. The cubed root of x cubed. This x comes out. This x squared stays. This y stays. So on the outside, I have 3x. On the inside, I have the cubed root of what stayed? A 3, an x squared, and a y. All right. Fourth root. Well, 2 to the fourth. Hey, 2 to the fourth is 16. So now, 2 to the fourth. X to the eighth. Break that up into some 4s. How about x4, x4? That makes 8 together. Because remember, you add exponents. Y to the 12th. I can make those a lot of 4s. Y to the fourth. 4. 4 plus 4 plus 4. That makes 12. So now let's take out what we can. 2 to the fourth. The fourth root of 2 to the fourth comes out as just a 2. The fourth root of x to the fourth comes out as just an x. The fourth root of this x to the fourth comes out as just an x. The fourth root of y to the fourth, just a y. The fourth root of y to the fourth, another y. The fourth root of y to the fourth, another y. Everything came out. Awesome. 2 x squared, y to the third. All right. 2 is on the outside. Now I have a cubed root. Cubed root is like 2 to the third is 8. 3 to the third is 27. Did 8 or 27 go into 40? 8 times 5. Oh, sorry, my lights just turned out. 8 times 5. So, the 2 is on the outside. 8, cubed root of 8 times 5. Break up x to the fourth into a third. x3 and x. Break up a y to the ninth into a y3, y3, y3. 3 plus 3 plus 3 is 9. since it's a cube root, I want lots of cubes. This is 2 to the third, remember? 2 to the third is 8. Okay, this 2 stays out. This 8, cubed root of 8, is a 2. The 5 is going to stay. X cubed comes out as x. This x is going to stay. Y to the third comes out as y. Y to the third comes out as y. Y to the third comes out as y. Everything that came out is 2 times 2, an x, and then y to the third. Inside the cubed root is a 5 and an x. So you have to look at the root to see what we're doing here. This was a cubed root, this was a fourth root, and this was a cubed root. All right, you for homework are going to do 36, 37, 38, 39, and then all of this elephant page. Okay? So the 36 through 39 and all of this elephant page here. It's matching. Make sure to read the instructions. All right, great job.